Hello scholars, welcome to Fun Scholar. So today we are going to discuss about the chapter Understanding Quadrilaterals. This chapter will be beneficial for class 8 CBSE student, but it will also be beneficial for ICSE board students. Okay, so let's start. So here understanding means samajhna ba boja, and quadrilaterals means something which has four sides, okay, just like this one or this one. Okay, so quad means four and laterals means this. Okay, so from this one we can understand that something which has four sides and they are lateral means parallel to each other, so that will be called as quadrilaterals. Okay, so if I start from the beginning, like we have already learned that this one is triangle because it has three sides. Tri means three sides, and it is something which is a closed figure, so this is called as a triangle. So the same process, something which is a closed and have four sides will be called as quadrilaterals. Now tell me, there are so many examples which we have been learning since our childhood or since when we have started learning geometry, that is square, rectangle. So these are the geometrical shapes which we have started learning about since we were child or since we have started learning geometry, and after that we have become a little older, so then we have started about learning about rhombus, and then comes trapezium. Okay, so in this chapter, and now we are in class 8, we have grown much older, and now we have to learn that we have all learned about the shapes, that how it looks like, but in this chapter we are going to learn that what will be the properties and how they act differently from each other's shapes. Okay, so let's go into the deeper. Okay, so look carefully, we have all kind of shapes here, like this one is a rhombus, this one is a rectangle, this one will be a right angle rhombus, we will going to learn about it later. This is a rectangle, this is also a rectangle, this is also a rectangle. So special quadrilaterals, zero pair of parallel lines, this will be kite, just like this. This is the special kind of rhombus, and two pairs of parallel lines. So the quadrilaterals which has two pair of parallel lines will be termed as parallelogram, rhombus, rectangle and square, and those quadrilaterals which have one pair of parallel lines will be termed as trapezoid or isosceles trapezoid, or in a combined we can call them trapezium. Okay, right? Let's go to the next one. And we have all kind of diagrams of all kind of these shapes. Now let's go further. So introduction to quadrilaterals. A quadrilateral is a polygon with four sides, four vertices and four angles. The sum of the interior angles of a quadrilateral is always 360 degree. Interior angle sum, okay, I will discuss about it later. So first understand that a quadrilateral is a polygon, and we know that polygon are those particular geometrical shapes, and it will we don't really start it from 3, we start it from 4. That if a polygon has 4 shape, that will be called as a quadrilateral, which we are currently studying in. When you go further, you will also learn that when a shape has 5 sides, that will be called as a pentagon. when a shape has 6 sides, that will be called as a hexagon, and then like this it will be heptagon, octagon, nonagon, decagon. Okay, so these all will be called as a polygon. Some books or some scientists may differ with this, that is a triangle a polygon or not. Some say yes, some say no. Some say yes because triangle follows some rules of polygon. Okay, and what are the rules of polygon, we will discuss it later. Okay, this is not included in your curriculum, but if you want to learn about it, we have some scopes to learn about it in this chapter as well. Okay, so talking about the quadrilateral, coming back to quadrilateral. So quadrilateral is a polygon with 4 sides, 4 vertices and 4 angles. The sum of the interior angles of a quadrilateral is always 360 degree. So if this one is a quadrilateral, and these all will be the angles of this quadrilateral, and the sum of all 4 angles will be 360 degree. Okay, and this will be called as the interior angle sum. For any quadrilateral, the sum of the interior angle is 360 degree. So if I elaborate it, so it will be like, here we have all kind of quadrilaterals, like this one is square, this one is rectangle, these two will be trapezoid, this is a parallelogram, this one will be kite, and this one will be rhombus. But one thing they have will be same, that is all these 4 angles, sum of these all 4 angles will be 360 degree. Okay, sum of all these quadrilaterals cones will be 360 degree, and this specific property will be termed as the interior angle sum, right? Okay, let's go to the next one. Okay, these closed shapes that are made up of line segments are called polygons. The polygon with the least number of sides is a triangle, which also happens to be a shape of the signboard indicating slope. Okay, just like I am telling you all this, that starting from triangle, because it has 3 sides. Okay, all the closed shapes made up with line segments will be termed as or are called polygons. The polygon with least number of sides is a triangle. Okay, just like this one is a triangle, this one will be a quadrilateral. Okay, and what I was supposed to telling you, that also that some scientists or some mathematicians don't consider triangle as a polygon. They consider triangle as a closed figure, but don't consider triangle as a polygon. And why they don't? Because a triangle sometimes doesn't follow all the rules of a polygon. And what are all the rules of a polygon? We will discuss it later. It is not that necessary right now. Okay, so definition of polygon is a closed shape figure that is made up of line segments only. Okay, so this one is just a simple description of polygon. Okay, and later we will also learn about that all the properties of polygon also, but let's stick to the quadrilateral. Okay, next video time. What is quadrilateral? So let's watch the video here. Okay, so this one is the first video, so that's why I am playing it. And you guys know that I generally skip playing videos in a running class, but let's watch this one. Okay. Sorry, it's taking a little time. Okay, let's watch this video, pair sides and angles. So this will be described easily as the polygon.
Consider a quadrilateral ABCD. We know that every quadrilateral has four sides, four vertices and four angles. In this video, we will understand that when it comes to quadrilaterals, what adjacent and opposite mean. The term adjacent means next to each other. In a quadrilateral, they can be angles, sides or vertices. If they are adjacent, they are next to each other. Then what does opposite mean? It's simple. It means not next to each other. Just remember these two things and you will never be confused about what adjacent and opposite mean in a quadrilateral. Let's first focus on the sides of the quadrilateral. So which are the adjacent sides in a quadrilateral? These two sides are next to each other. We can say that the sides AB and BC are next to each other. The sides CD and CD are also next to each other. These two sides and these two sides are also adjacent to each other. If you observe, all the pairs have a common vertex. The first two sides have D as their common vertex. The second pair has C as its common vertex. So adjacent sides in a quadrilateral will always have a common vertex. Which are the opposite sides then? One pair would be AB and CD. They are not next to each other. Another pair would be AB and BC. Remember, there are only two pairs of opposite sides in a quadrilateral. And notice that the pairs have no common vertex. So the opposite sides of a quadrilateral have no common vertex. Let's zoom out a bit and talk about the angles in this quadrilateral. What are the adjacent angles? Adjacent angles are angles that are next to each other. These two angles are next to each other. So angle ABC and angle BCD are adjacent angles. Similarly, these two angles are also next to each other. We can say that angle CDA and angle DAB are also adjacent angles. This pair and this pair of angles are also adjacent. What do you notice about adjacent angles? Yes, they all share a common side. These two angles have BC as their common side, and these two angles have DA as their common side. So what about opposite angles? There are only two pairs of opposite angles. This pair and this one. Angle DAB and angle BCD is one pair, and angle ABC and angle CDA is another pair. Angle DAB and angle BCD are opposite to each other, and angle ABC and angle CDA are opposite to each other. And observe the opposite angles. They do not have a common side. And that's why we say that opposite angles have no common side. You don't need to memorize all this. All you need to know is that adjacent means next to each other and opposite means not next to each other. Let's see one last concept in this video. Consider this table to be a plane surface. Assume we place a quadrilateral shaped piece of paper on it. This green portion inside is called the interior region of the quadrilateral. This blue portion outside the quadrilateral is called the exterior of the quadrilateral. And the red line on the boundary of the quadrilateral is the portion that is on the quadrilateral. Let us name a quadrilateral A, B, C, D. The interior of the quadrilateral ABCD, that is the green region, plus the quadrilateral ABCD, which is the red boundary, together are called the quadrilateral region.
so from this video, I know that this video was quite a bit long, but from this video we have learned that quadrilaterals are of 4 sides, and quadrilateral has 4 vertices, 4 sides and 4 angles. Okay, so and also learned about the adjacent angles or adjacent side. Okay, so AB and AC, so this is will be like we have learned about that AB and DC are opposite to each other, and just like the same way AD and BC are opposite to each other. And talking about adjacent, so this one is adjacent. Adjacent means that they are joining each other by point B. The same way BC and CD will be adjacent, and AD and DC will be adjacent, and DA and AB will be adjacent. Okay, and AB and BC and CD and CB will have common vertex. Okay, just like AB and BC and CD and CB. CD and CB will have common vertex, and vertex will be C and B, and just like there also will be A and D. Okay, so this was the topic. So here is the video. So let's go to the next one. Okay. Okay, things to know about quadrilaterals. Okay, so that I have already explained that quadri means 4 and lateral means sides. Okay, so 4 vertices. So we have they have given some examples like TV monitor or envelope or drawing board. Okay, a copy in a table, and the table itself also, they all have 4 vertices, that is A, B, C and D, just like this, and it is all in the same plane, and it has 4 angles like A or DAB or BAD, ABC, BCD, CAD or CDA. Okay, if I explain it by this one, okay, so this is an example of a square, and this is also this will also be a quadrilateral because it has 4 sides, and these all 4 sides will be the vertices of this square or quadrilateral. Okay, and the 4 sides will be this from this to this, this to this, this to this, this to this. Okay, and the 4 angles will be this, and this. Okay, and you can also try it whatever you are having closer to your hand. Okay, so maybe you are watching this video with the help of mobile. So mobile is also an example of a quadrilateral or a rectangle. Okay, I am recording this video with the mobile, so this is also a rectangle, and it also has 4 vertices, 4 sides and 4 angles. Okay, let's go to the next one. Okay, there is another video, I am not playing it. What are the different pairs of sides and angles in a quadrilateral? We have already showed the glimpse of this in the previous video which I have played. Now let's see this in help of this image. Different pairs of sides and angles in a quadrilateral. Okay, so here are 4 sides. The adjacent side like AB and BC, CD and CB. Okay, so adjacent is next to each other, and opposite means not next to each other. So the opposite sides will be AB and CD, which I have already told it about. Okay, and the angles will be A, B, C and D. You can also write it like DAB or BAD, ABC or CBA, ADC or CDA, and BCD or DCB. Okay, and they have all wrote it like this. Okay, and maybe you have also know that because I can write angle A can also be written as BAD or DAB, where both A will be in the middle and A is referring the angle itself. Okay, and talking about side don't have anything much to do with it. So AB and BC and CD and CB will be the adjacent side of this, and they have also, and why they are adjacent? Because they have the common vertex. Okay, and why they will be termed as the opposite sides? Because they don't have any common vertex. Okay, and talking about angles, so we already have learned about the angles of the adjacent sides. Okay, so these four will be, and talking about opposite angles, that angle A's opposite angle will be angle C, and angle B's opposite angle will be angle D, because they don't have no common sides. Okay, let's go to the next one. Okay, what is a polygon? I have already told it about, and it's won't be very beneficial to play the video, so you can watch the video peacefully in your home using the app. I am not playing it here because this video won't be any beneficial, very much beneficial. Okay, so talking about polygon, I have already told that pentagon, hexagon, heptagon, octagon, nonagon. You can also try to check the sides of this. Okay, like this one is pentagon. Why this is pentagon? It has 5 sides. This one is hexagon. Why this is hexagon? Because this is also has 6 sides, like heptagon, octagon, nonagon. All they have much more sides. Okay. Okay, I am talking about polygon. Polygon more than 4 sides. Okay, a simple closed figure formed by line segments in the same plane. Okay, so they are trying to say that polygon means, and it's not like the polygon has so many sides. Okay, yes, it can be so many sides if that is a closed figure like this. Something which has a closed figure like this. Okay, this one is circle, this one is not polygon. I am just giving example by drawing this, that a figure has to be closed. Okay, they don't have to be like this, that it has something in open. So they have to be like close to make a polygon. And triangle and quadrilateral, they will start from triangle and end in maybe like there are infinity number of sides can be present in a polygon. So they will start from triangle. The simple closed figure formed by line segments in the same plane will be called as the polygon. Okay, right, let's go to the next point. Okay, they have given the examples of all kind of polygons. Okay, triangle 3, quadrilateral 4, pentagon 5, hexagon this one, and you can also try it. Okay, you just think about a number which is greater than 3, and you can draw whatever the shape you like, but the condition is that shape has to be a closed shape, and that will be called as the polygon. Okay, just like look at this, like they have heptagon. Look at this, they have drawn it like this, and we already show that heptagon can be like this, 2, 3, 4, 5, 6, 7. Okay, this can be like this. One, two, three, 4. Okay. Yes, this one is quite looking like a heptagon, but you can also have drawn like this. So they have drawn it like 1, 2, 3, 4, 5, 6, 7. Okay, you can also draw it like this. Okay, so these all are, if you have spare time, so you can all draw like this to check whether it's a polygon or not. Okay, let's go to the next one. Okay, what is a regular polygon? Okay, and the regular polygon is basically something which is not whose shape is not like this or something, which starts from a side and ends in a side like a circular form. that will be called as a regular polygon, just like this one. Okay, all sides are equal, all angles will be also equal, and like this one is a regular hexagon. Okay, I haven't played the video yet. So this is quite simple. Let's go to the next one. Okay, regular and irregular polygons. Okay, the regular polygons are all sides of a regular polygon are the same length and all of its angles are the same measurement. Okay, just like this triangle, square, and they all are the polygons which will be called as a regular polygon, because like see like this one, like an equilateral triangle has all sides are equal, like a square also has all sides equal, right? And for a pentagon, like this side will be equal as this side no, not this side will be equal as this side. Okay, so this will also be a regular pentagon. I'm talking about hexagon because this has even number of sides. They all opposite sides will be equal. Okay, so that's why we are calling all these as the regular polygons. Okay, and now coming to irregular polygon. And talking about irregular polygon, it's just the opposite of regular polygon. What is? So basically, irregular polygons, they don't have opposite sides equal. Okay, so it will be like a trapezium. Trapezium is a quadrilateral, and it will be also a irregular polygon because they don't have something. This side and this side is equal, but this side and this side are not. Okay, and talking about triangle, and think it about a scalene triangle. Okay, this will also be an example of irregular polygons. Okay, and these are all the shapes. They are just a closed figure and they will be termed as a polygon, but they are not regular polygons. They will be termed as the irregular polygon. Okay, right? Let's go to the next. Okay, diagonal of a polygon. A line segment joining two non-consecutive vertices is called as diagonal. Let us see how many diagonals are there in the following polynomials. Okay, so talking about diagonals, we already learned about it from square and rectangle. Like this rectangle has two diagonals and they will start from here and will end here. Okay, maybe these lines are not the straight, but you can easily understand that these will be the diagonal. So this one is rectangle, and in my hand I have a square, a model of a square, or a two-dimensional or three-dimensional model of a square. So the diagonal will be the middle part joining in it. Okay, so this will be called as the diagonal. But what about the polygons? Like if you for quadrilateral it is okay, but what about a pentagon or hexagon? So for those cases, the line segment joining two non-consecutive vertices is called as the diagonal. Let us see how many diagonals are there in the following polynomial. So line segment from a vertex of polygon to the vertices of non-adjacent sides. Okay, the diagonals divide a polygon into triangles. Okay, so if I start from this point, so look at this, these two sides will be called as the adjacent side. Why? Because they have this point in common. So we have to make or draw diagonals to the opposite points. Starting from this point will be look like this. We can draw it from here, here and here. Okay, and these two are the adjacent side, so it can't be drawn from it. Okay, right? So let's go to the next one. Okay, what is the formula to find diagonals? Okay, and I was just telling you about all that why triangle does not follow the certain formulas of polygon. That's why some mathematicians don't consider triangle as a polygon, but in your book or in this slide they have considered it. But you can also think that if I draw a triangle, a triangle don't have any diagonal. Okay, so simply triangle will not justify this formula. So what they are telling that a diagonal of a polygon. Okay, so the formula of this will be n into n minus 3 by 2. Okay, so talking about n, a polygon who have, if a polygon has 10 sides, so the total number of diagonal of that polygon will be 10 into 10 minus 3 by 2. Okay, the answer will be 10 into 7 by 2 and the answer will be 35. Okay, the formula will be this. The formula will be this. Okay, the formula to calculate the number of diagonal of an n-sided polygon is this, n into n minus 3 by 2, where n is the number of sides of the polygon. Note, there is only one polygon which has number of sides and number of diagonals same, and it is pentagon. Okay, so this is a special note. And why they are having this? So 5 into 5 minus 3, if I do like this, it will be 5 into 2 by 2 and the answer will be 5. 2 will be cancelled and 1 will be the answer. So the 5. So if I draw a pentagon, the pentagon will also have 5 diagonals. If you start from here, it will go from here and here. If you start from here, it will go here and here. Okay, and if you start from here, so these 2 points are done, and yes, okay, so 1 2 3 4. Okay, you can simply draw this in your home, or if I have time, so I can also draw this. So there will be 5 diagonals. Okay, next, convex and concave polygon. Okay, maybe you all have learned about in physics that you have words like convex and concave. So the convex polygon is a polygon with all interior angles measuring less than 180. The vertices of convex polygon point away from the shape's interior. Okay, so these all will be convex shape. So why they will be called as the convex? Because the interior angles measures less than 180 degree. Okay, the vertices of the convex polygon point away from the shape's interior. The only thing is to remember that the interior angles measuring less than 180. Okay, so like this one, 1 2 3 4 5, it is a pentagon, and for us these shape they have the interior angle sum property is 180 degree. So that's why they will be termed as the convex polygon. Okay, 180 or less than 180. Okay, concave polygon, a polygon with at least one interior angle measuring more than 180 degree, at least one vertex of concave polygon points inward towards the shape's center. Okay, so at least one interior angle, if I like, you can think like this, measuring more than 180 degree, at least one vertex of concave polygon points inward toward the shape's center. Okay, so we will discuss it about later. Next, let's go to the next. Let us see some more convex and concave polygons. Okay, so they all are convex polygons and they all are concave polygons. Okay, and why? I already told that we will discuss it later. So they are talking about these concave polygons like all this. The angle of this will be towards the center, and the angle, this angle will be less than 180 degree. So that means that this angle has to be more than 180 degree, and it is will be like this. Okay, and sorry. Okay, measuring the interior angle, measuring more than 180 degree. Okay, so they are all covering this they are all covering these properties. Okay, right? Okay, sum of the measure of the exterior angle of a polygon. Sum of all interior angles of a polygon is 360. Okay, so talking about what we have already learned in the concave and convex polygon, that the interior for triangle, we already know that the angle sum property is 180 degree. So because of this property, a triangle is a concave polygon, and sum of all exterior angles of a polygon is 360 degree. Like if I talking about this pentagon 1 2 3 4 5, this pentagon, the sum of all exterior angles of a polygon is 360 degree. Like 1 2 3 4 5, they all are the exterior angles and their sum will be 360 degree. Okay, let's go to next. Sum of angles of a polygon. In a quadrilateral, number of triangle is 2, therefore angle sum of quadrilateral is 2 into 180 degree. In a pentagon, number of triangles is 3, hence angle sum of a pentagon will be 540 degree. In general, angle sum of a polygon of n sides will be n minus 2 into 180 degree. Okay, I am letting you okay, I am discussing it. If I draw a diagonal in a quadrilateral, so the diagonal will divide it into triangles. Okay, a triangle has only one triangle, but for a pentagon there are 3 triangles over there. Okay, it will be like this, this and this. Okay, and you can also draw the diagonals of it to separate it, and the number of sides is 5. Sum of the angles will be this rule. This will follow the rule of this n minus 2 into 180 degree. Okay, in a quadrilateral, number of triangle will be 2, 1 and 2. Okay, so if I separate this will be look like this. Okay, so that's why they will all follow this rule. Now let's see a video. Okay, this video maybe this video is not needed now. You guys can watch the sum of exterior angle of a triangle. Okay, let's watch this one.
So far, we've understood how to find the sum of angles of a polygon. Now, how do we find the sum of exterior angles of a polygon? Let's understand this with the help of this pentagon. Here, A, B, C, D and E are the angles of the pentagon, while V, W, X, Y and Z are the exterior angles. We need to find the sum of these exterior angles. So, let's begin. Observe that the angles A and B form a linear pair, and does that mean? Yes, it means A plus B will be equal to 180. We can write B as 180 minus A. Also, we have other linear pairs, namely B and W, C and X, D and Y, E and Z. On similar lines, we get these relations. Now on substituting these values, we get the sum of exterior angles as this. This is equal to 180 multiplied by 5 minus A plus B plus C plus D plus E. Now what does this 5 signify? Yes, this 5 is the number of sides of a pentagon. And what is this equal to? Correct. This is nothing but the sum of the angles of a pentagon. Wow, so we have a relationship in terms of the number of sides of a pentagon and the sum of its angles. We can generalize the statement for any polygon with n sides. So the sum of the exterior angles of a polygon with n sides will be equal to 180 multiplied by n minus the sum of angles of the polygon. Now, do you remember the formula we had derived for the sum of angles of a polygon with n sides? Yes, it's given by n minus 2 times 180 degrees. Substituting this in our equation, we get this. Now, on simplifying the right-hand side of the equation, we get this. So the sum of the exterior angles of a polygon with n sides is equal to 360 degrees. Hang on, did you notice something? The right-hand side of the equation is just a number independent of n. Well, this means, irrespective of the number of sides of a polygon, the sum of its external angles will always be equal to 360 degrees. That was fun, isn't it? We hope that you've enjoyed this video. To learn more about polygons and other interesting topics, do visit Don't Memorize.
Okay, so we have watched the video here. Okay, now let's recap the angle sum property a little bit, because I haven't played that video yet. So sum of angles of polygon with n sides is n minus 2 into 180 degree. Sum of angles of a triangle is 180 degree. We already know that. So for quadrilateral, the sum of angles will be like this. For pentagon, the sum of angles will be like this, and hexagon will be like this. And why they are just like here, why they have written it like this, because the angles are not known. So that's why for quadrilaterals, the sum of angles they wrote it like this, but for us we can tell that sum of angles will be 360 degree, because we already have learned it yet. Okay, learned it before. So let's go to the next one. Okay, important formula: all the angles in a regular polygon are equal. Okay, video we have already watched the video. So the exterior angle will be like this and interior is this. The sum of all angles formula for interior angles is this, and the sum of exterior angle will be like this. Okay, and so these two are just the normal formulas, okay, which you have to keep in mind. So let's go to the next one. Time for a recap. So find the number of sides of a regular polygon whose each exterior angle has a measure of 45 degree. Okay, so the total measure of exterior angles is 360 degree. We already know that. So measure of each exterior angle is 45. So therefore the number of exterior angles will be this. Okay, they have taken this formula. Okay, so the exterior angle, we know that the sum of all exterior angle is 360 degree. So from this we have to just divide 360 by 45. So we will get the answer like this, I guess, and they have already done that. Okay. So find the value of A in the given pentagon. Okay, so this one is quite easy. Okay, try to do it. You have to just find the value of this one will be 105, this one will be 110, this one also will be 110, and this one will be 65, 30, 15, 115 maybe, 115. And sum of the all exterior angles, we already know that 360 degree. So 70 plus 70 is 140, 140 plus 65, 105 and 65 is 170 plus A equals to 360. We already know that. So from that we can say that 360 minus 200, 310. So 50 degree will be the answer. Okay. Oh, sorry, we have maybe we have made a mistake. Yes, 65 and 70, 65 and 70. Oh, maybe we have made a mistake here. So 70, 70, 140, and this will also be 70, 70. So it will be 140, 140 plus 140, that will be 280. So 360 minus 280 will be 80, right? Yes, we have made a little mistake by adding these two numbers. Okay, so you can also 70, 70, 140, and 75 and 65 also becomes 140, and just subtract it from 360 to get the answer. Okay, properties of two-dimensional figures. Sum of interior angles of a hexagon is. Okay, so this is for your Holmes question. Okay, and talking about this, just apply the formula, that is n minus 2 by 3 into 360, and you can clearly solve this. Sum of the four interior angles of a quadrilateral is 360 degree. Okay, so this one is just they have rotated down. This is the angles are property of a polygon, and we have already watched the video here. So what is the value of x in the pentagon below? Okay, they just want to know about the value of x. So, and this is a this explanation of this one will be a very big. Recognize the sum of the interior angles of a polygon. Okay, so this is a pentagon. So sum of the interior angles will be n minus 2 into 180 degree is 540. Now use the given information that y plus 78 will be 180, like y plus 78 will be 180 because they are making a straight angle, so it will be 180. So from that point we can simply find the value of y. Okay, and write the equation for the sum of the interior angles of the pentagon, which is x plus 10. Now again write all the equation again, and we already know the y's value. So from that we just simply find the x value of x. Okay, so what they did, what they have done, that first of all y's value will be 180 minus 78. Okay, it will be like maybe 102. Right, and from this, and we already know that the all sum of all this will be 360 degree. So from 360 we have to minus the addition of all this. Okay, so it will be 108, right? Okay, now we have learned so many things about the polygon, but the chapter's name is understanding quadrilateral. So let's come to the quadrilateral again. Okay, so start from parallelogram. So this one is parallelogram. Okay, and for parallelogram we have just opposite sides are parallel, will be termed as the parallelogram. So for this reason rectangle, rhombus, square will also be called as the parallelogram. Okay, from quadrilateral we can say that parallelogram is a type of quadrilateral, but parallelogram also have some options where they have rectangle and square as the parallelogram. Okay. Okay, so if you don't if you getting puzzled about all this, so just forget about that and just know that all these kind of shapes will be termed as the quadrilateral. Just like square, rectangle, parallelogram, trapezium, rhombus, kite, all are the types of quadrilateral because they all have 4 sides. Okay, so these all are quadrilaterals. Now next, so let's start from parallelogram. So a parallelogram is a quadrilateral where opposite sides are parallel and equal in length. Just I am telling you guys about this, that this side is parallel to this side, this side is parallel to this one is parallel to this one. Okay, opposite sides are parallel and obviously equal. Okay, just like this one will be equal as this one. Okay, and opposite angles are equal in measure. This angle will be equal to this one, and adjacent angles are supplementary. Okay, and talking about adjacent angles, so that is sum of these two angles will be 180 degree. You already have learned about supplementary and complementary angles, that if two angles addition x and y are two angles makes 90 degree, so y will be called as the complementary of x and x will be called as the complementary of y. The similar thing will be, we also can tell about this 180 degree. So that one was complementary, this one will be supplementary. Okay, and maybe you all guys have know about this. Okay, and now number 4, diagonals bisect each other. Okay, so diagonals bisect each other, so they make 4 equal squares. Okay, bisecting means dividing into the equal parts. Okay, right? So next, let's watch the video because this video is quite important. What are trapeziums and kites? Yes.
Previously, we looked at the basics of quadrilateral. Now we will study their different types. Look at this quadrilateral ABCD. In this quadrilateral, this pair of opposite sides is parallel. AB is parallel to CD and the other pair of sides is non-parallel. So AD and BC are the non-parallel sides. This kind of quadrilateral, where only one pair of opposite sides is parallel, is called a trapezium. Sometimes the non-parallel sides are equal. Quadrilateral would look something like this.
Okay, so we already learned about parallelogram, and in this from this video we have learned that a trapezium, learned about a trapezium and kites. Okay, so let's discuss it a little bit. Like for trapezium, AB and CD will be parallel to each other. That means that they won't touch them, or they don't cross each other ever. Okay, but they are not parallel like AD and BC. Like if one is like this and one is like this, they easily can like touch here. Okay, so these two lines are not parallel, so one pair of parallel lines will be called as the trapezium. Okay, and it has non-parallel sides at AD and BC. And talking about isosceles trapezium, they have AB and CD, AD and BC. AD and BC will be equal. Okay, and these will be called as the isosceles trapezium. And so from this one you can also ask that sir, is these two lines are not equal? No, these two sides are not equal. Maybe in the image you are seeing that it looks like equal, but actually they are not. Okay, so got it. Now the next will be kite. Okay, for a kite there are two pair of adjacent side, so and they will be equal, and they will be equal. Like for this one, the adjacent sides are D and A, AD and DC, and it has adjacent side of AB and BC, and BC and BD will be equal. So two pair of adjacent side like this one and this one, this one and this one will be equal. So that's why that will make a kite. Okay, and talking about kite, it's actually a object or a real life object. It's not just about a shape, it's an object which we use in our daily life. Okay, and the opposite sides are unequal, right? And opposite sides are unequal. Obviously this one is unequal to this one and this one is unequal to this one. Okay, so this is a kite. Next, a trapezium is a quadrilateral with only one pair of opposite sides parallel. Like for this one pair of opposite sides are parallel. This one is parallel to this one is parallel to this one. Sum of all angles on each of non-parallel side is 180. Now non-parallel sides are equal. Okay, this one is equal. Oh, you have already told that these are just property, like angle B and angle C will be complementary, that is supplementary. This will be 180, and angle A and angle D will be again 180 degrees. So this is a property. And one pair of opposite sides are parallel, sum of angles, that is like this one, and no parallel sides are equal. So and they are not equal. Okay, in the following figure, ABCD is a trapezium which AB parallel to DC. Find the measure of angle C. So angle C's measure will have to be found by us. So how can we find this? Okay, so this one and this one will be supplementary, that will be 180 degree. Okay, and talking about the supplementary angle, so this will be 60. So this will be 60, right? And they have asked us that the measure of angle C, and the whole point will be, so if this is 60, this will also be 60, and this will also be 120, because because the sum will be 360 degree. Okay, so this is the solution. Okay, a kite is a quadrilateral with two pair of adjacent sides equals. The properties will be two pairs of adjacent sides are equal. Okay, one pair of opposite angles between the unequal sides are equal and diagonals intersect at right angles with one diagonal bisecting each other. The first one is two pair of adjacent sides are equal. So this one equal to this one, and one pair of opposite angles between the unequal sides are equal. Okay, so this one will be equal to this one, and diagonals intersecting at right angles with one diagonal bisecting each other. So they are in a right angle and this one is bisecting each other, right? So these are just the properties, and maybe we need something for the further cases. Okay, kites, diagonals are perpendicular. So this means perpendicular. So this is a theorem. Okay, maybe I haven't taught you guys about the theorems, but in this chapter or upcoming geometry chapter we also has proof of theorems. So from this one we have a theorem like diagonals are perpendicular to each other. So for this case we have to draw a kite. Okay, they have already drawn it, but I am drawing it again. So a kite who has A, B, C and D, and it has two diagonals like this who have joined in O, and from this we can say there are two triangles here. Okay, one is BOA and one is BOC. So from this one we can tell that BC and AB will be equal, because from kites properties we have to know that adjacent sides are equal, so that is given already. So CBD and ABD, CBD and ABD will also be equal because this one is the common side and they have already bisecting it. So that's why this one will be, one is given, two is already being proved, and number 3 is also proved. So from these three we get from the SAS congruency, the congruence chapter you have already done in class 7, that these two triangles are the triangles are congruent to each other. Okay, so from this we can also tell that the BOC and BAE are the equal because they are following the SAS congruency. So from this we can tell that they are linear pair because BOA and BOC are linear pair because they are in one line. So they will be, if this whole is 180 degree, so they are each making 90 degree as each. Okay, done. Okay, the next one, question. ABCD is a kite in which diagonals intersect at O. If AD is equals to AB, CD is equals to CB, find the measure of OCB. Okay, so to find the OCB, we already know that angles in an isosceles triangle, this is already been given. Okay, now we have to measure OBC. So the measurement will be 100 minus 140. Why we are doing this? Because we already know that these two angles are congruent triangle. Okay, so step 2 will be the measure of OCB. Now measure of OC and B, and this is will also be done like this, that 3 measurement will be 180 degree and the measurement will be 30 degree. Okay. Next, what is the parallelogram and what is special cases? So
see that AB is parallel to DC. We use two arrows in the same direction to show that the sides are parallel. The second pair of opposite sides is AD and BC. We can also see that AD is parallel to BC. So we draw arrows like this. Such quadrilaterals are called parallelograms. Both pairs of opposite sides are parallel. This was the basic property of a parallelogram. In a parallelogram, opposite sides are also equal. This side will be equal to this side. We can say that AB is equal to DC. This side will be equal to this side. AB is equal to BC. And guess what? In a parallelogram, the opposite angles are also equal. Opposite angles are angles which do not have a common side. This angle will be equal to this angle. Angle DAB is equal to angle DCB. And this angle will be equal to this angle. Angle ABC is equal to angle ADC. Remember, this is the basic property of a parallelogram. The opposite sides as well as the opposite angles are equal. Let's see a special case of a parallelogram. In this parallelogram, all the sides are equal to each other. This is a rhombus. So a rhombus is a parallelogram with all its sides equal. It will have all the properties of a parallelogram as well as this additional property that all its sides will be equal. There is another special case of a parallelogram. Let me draw it on a new page. Remember, the opposite sides have to be parallel. It is a quadrilateral drawn like this. The opposite sides of this quadrilateral are parallel, so it is a parallelogram. Let's name the quadrilateral ABCD. Why is it special? All the angles in the quadrilaterals are right angles. This special case of parallelogram is called a rectangle. This is how a rectangle can be defined. It is a parallelogram with all angles being right angles. Just like in a parallelogram, the opposite sides of a rectangle are equal. This side will be equal to this side, and this side will be equal to this one. Now it gets even more interesting. This quadrilateral is a special case of a rectangle. Let's call it PQRS. Like the rectangle, all its angles are right angles, but it has an additional property. All its sides are equal to each other. This type of quadrilateral is called a square. Basically, it is a rectangle with all its sides equal. The rectangle is the special case of the parallelogram, and this square is a special case of a rectangle. But wait, in a square, the opposite sides are parallel, so it is a parallelogram. All its sides are also equal, so it's also a rhombus. Again, what is a rhombus? It is a quadrilateral with all its sides equal and opposite sides parallel to each other. But how is the square different from a normal rhombus? It is a rhombus in which all angles are right angles. Next, we will review all the types of quadrilaterals and how they are related to each other.
So already I was telling that that rectangle square can also be termed as the parallelogram, and parallelogram is also a quadrilateral. Okay, so for parallelogram, both pairs of opposite sides are parallel, and when all sides are equal, that will be called as rhombus, and when all sides will be parallel and equal, I mean each pair will be equal, like for this pair will be equal as this pair and this pair will be equal as this pair, then that will be called as the rectangle. And when each each side as well as angles will be equal, then that will be called as a square. Okay, so this is the all special cases of parallelogram we were discussing about. Now the next we will go up to that what does it mean actually, that I have already told that for parallelogram only the opposite pairs, if the opposite pairs are parallel to each other, that will be parallelogram. And again talking about rhombus, square and rectangle, they all have their different varieties. Okay, so this is the, so in a parallelogram one angle is 70, what are the other three angles? Okay, the solution will be opposite angles are equal. So for 70 degree the opposite angle will also be 70 degree, and the consecutively the parallel angles will be like, if this one is 70 degree, this one will also be 70 degree. Okay, and this one is 110 and this one will also be 110. This is the example of a parallelogram. Okay, so let's go further, and the answer is tells the right. Okay, and from next class we will start from our rectangle. Okay, so let's end it here. Okay, so this is the lecture 1 of understanding quadrilateral, and we have already finished up to parallelogram. From the next lecture I will start from rectangle. Okay, thank you everyone, have a good day.